Continuing on with first order non-homogeneous differential equations. Again, we looked at the first two problems and the solutions we had. You could say that for y prime is equal to x times e to the x, we took a method of undetermined coefficients approach to solving. In other words, we had this analogous to y is equal to the integral of x times e to the x dx, where we had that set of terms earlier. And of course, for the integral of 5 dx, we have 5x plus a constant. And now this third case is going to be a bit of a doozy, regardless of whether you are using integration. And like here for 3x squared e to the x, you would have a case of repeating integration by parts. But if we look at applying through the lens of utilizing the method of undetermined coefficients, and again we have a homogeneous first order differential equation. And now again, for the overall solution, you're looking at combining the complementary and the particular solutions. And again, for the complementary solution of a first order homogeneous differential equation, okay, that is just going to be a constant. And looking at what we have with the terms and going back to what we have referencing families of functions. And if you notice with the first term, we have x squared times e to the x. And if we look at each of the variable factors and then cluster together, we have with x squared, again, you have in the family of derivatives. So you have x squared, and the derivative of x squared goes to x, and the derivative of x goes to a constant. Now, I would say we have duplication, and we would if I had just worked with 3x squared. But I'm looking at not 3x squared, but 3x squared times e to the x. And so we have with e to the x, we have with the family of derivatives, well, that is just going to be locked in at e to the x. So for what we have in the case of, let's say, 3x squared e to the x, and just putting it in the form of the consolidated family of functions, intertwining what we have with the elements with the respective families. So again, we have from the x squared part, we have x squared, x, and c. And we have times e to the x, and from e to the x, I have e to the x. And if I'm looking at distributing, okay, so I would take like all of x squared, x, and the constant and multiply by e to the x, and just go ahead and put in diminutive form. So you have x squared times e to the x. So you have x squared e to the x. Next, you have x times e to the x. And for a constant times e to the x. And just putting this already in diminutive form. So I'll just say that I have e to the x. So this is the family that we have here. And notice we do not have a duplication of a constant. Now, for what we have in the case of x times the cosine of x. Again, so we have with the x part, I have x and a constant. And again, if I had just an x term to work with, I would have a duplication. But I have not x here, but x times the cosine of x. And we have with the cosine of x. Okay, so putting out the family of derivatives. So we have the term at cosine of x, and the derivative of a cosine term is going to go to a sine term, and you'll have a bit of a loop, like cosine leading to negative sine, which leads to negative cosine, which leads back to sine. All of these we have as multiples of cosine and sine of x. And for what we have in the case of 3x cosine of x, from that term, we have to spring forth, again, multiplying what we have in the corresponding elements from the families of derivatives. So again, from x, we have x and a constant. So we have times, from the cosine of x, we have cosine of x. and the sine of x. Again, if I look at distributing, so you have x cosine of x. Yeah, so just mapping with x from the first. So x mapped with cosine of x, then we have x mapped with the sine of x. And we have, working with a constant, you have times cosine of x, and again, in diminutive terms, we have cosine of x. Constant times sine of x, again, we just put this as sine of x. And we have, in the case of 9x, okay, so this time we have a standalone x term. So I have from x, I have x, and derivative of x goes to a constant. And if you notice, okay, we have a duplication. And so anytime you have a duplication, okay, you can just multiply that family by x. So again, I'm multiplying by x to remove the duplication. So I'm going to have x squared, and c times x, I can just say that I have at x. So what I have in the setup for y sub p, I can just go ahead and cluster together what I have with the families of derivatives. So we have for y sub p, okay, so if I put all of these together, notice we do not have a duplication. So for what we have in the case of y sub p, now we're going to have, just for the general solution, again, we have several undetermined coefficients right now. So we have, like, starting out, we have y sub p is equal to ax squared e to the x plus bx e to the x plus c e to the x plus dx cosine of x plus ex sine of x plus f cosine of x plus g sine of x plus h times x squared plus ix. Okay, and okay, so I'm just going to duplicate this, and then I will take the first order derivative. Okay, so if I take the first order derivative of y sub p, we had this rather long line of terms, okay, and going back to our original equation and just putting y prime and just projecting that to the particular. So you have y sub p prime again is equal to 3x squared e to the x plus 3x cosine of x plus 9x. And if I set these two statements equal to each other, okay, so if we look at the corresponding parts, okay, so for what we have in x squared e to the x, okay, notice we have coefficient a on the left, coefficient of 3 on the right. So we can go ahead and say that a is equal to 3. And for what we have in the case of x cosine of x, so I have 3 on the right. And for what I have for x cosine of x, I have e. And we can go ahead and say that e is equal to 3. And notice we have 9x on the right. And for the x term on the left, I have 2h. So if I set 2h equal to 9, we'll have the h is equal to 9 halves. And notice, okay, we have no standalone constant on the right, and we have only I. So we can go ahead and say that I is negligible. And now if you notice, okay, say just with the standalone letters, you have dx sine of x, but you don't have an x sine of x term on the right, so d is going to be negligible. And we also have d and d plus g cosine of x, but we don't have a standalone cosine of x term. We got x cosine of x on the right, but not a standalone cosine of x. So not only is d going to be negligible, but d and g, or g, is going to be negligible as well. And for the variables we have not yet tackled, okay, notice we had a is equal to 3, and guess what? We don't have an x e to the x term on the right, but that doesn't make b negligible because we have 2a to be tied in. So we've got 2a plus b is equal to 0, and with a at 3, well, guess what? 2 times 3 is 6, plus b is equal to 0. So we're going to have that b is equal to negative 6, and guess what? Even though we don't have an e to the x term on the right, that doesn't make the coefficients automatically negligible because we have b to be non-negligible thanks to the appearance of a. And guess what? C is going to be non-negligible because we have a non-negligible value for b. And with b at negative 6, and with b plus c equal to 0, well, it's going to turn out that c is equal to 6. And for the remaining coefficient we have with f, well, we don't have a sine of x term on the right, but we have e minus f is equal to 0, and e is equal to 3. And it's going to turn out that f is equal to 3. So just relaying back to what we have here. Okay, so again, for y sub p, I got 3, b is negative 6, c is positive 6, again, d is negligible, e we have at 3, f also at 3, again, g is negligible, h we have at 9/2, and again, I was already negligible. Okay, so again, I is out of the picture, G is out of the picture, and D is out of the picture. So for what we're going to have, all in all, for our solution, we have y sub p is equal to 3x squared e to the x minus 6x e to the x plus 6e to the x plus 3x sine of x plus 3 cosine of x plus 9/2 of x squared. And so we have for the whole solution in the case of y of x. So that is going to be the solution. And going back, we're going to have for the integral 3x squared e to the x plus 3x cosine of x plus 9x. If you did the integration by parts and worked with the individual integrals, this will be your set of terms in the final outcome.